Hello everyone, how are you? I hope you all are doing great. Okay, now we are just discussing about the forces and laws of motion right now. So in the last class we have actually mainly discussed what is actually force. Then we saw some kind of examples of forces in our day-to-day life. We actually able to see how forces are actually going to work. Then we see that types of forces, contact and non-contact. Then we actually get some examples of contact and non-contact force. Then I told you that we are going to mainly discuss about the contact forces here, right? Then we get two main actually example or classification of the forces like balanced and unbalanced force. Then we discuss about that. Then we move towards one example, with an example actually that was given by the Galileo Galilei. Then we move towards using that example towards the first law of motion. Then we actually able to discuss that first law of motion is also known as the law of inertia. Then we actually discussed what is actually inertia. Then we discussed how inertia and mass are related. Simple. Now today we will start. In the last class we actually discussed that first law of motion, and I told you that there are three laws of motion, and those laws of motion are basically known as Newton's law of motion. In the last class we basically discussed the first law of motion, and today we will discuss the second law of motion. Okay, today we will mainly discuss second law of motion. Okay, it is also an interesting one. Okay, the first law, what it actually gave us, that actually first law says that once an external force is applied on an object, that object's motion is going to be changed, or what you can say, an object's state is going to be changed. Okay, simple, it's a simple concept, right? But now we will actually find a way to measure that force. Okay, or we will check. Once the force is applied, we know if the car is in motion, if some other car hits that car, from the back side, what is going to happen? Its velocity is going to increase, right? Or if the driver applies the brake, what is going to happen? Its velocity is going to be decrease. That means what? As a whole, the velocity is going to be changed. Once the velocity difference is there with time, what you can actually calculate? Acceleration. That means what you can say? With force, there is a change in acceleration too. Right? Now we will actually establish some kind of relations, using the second law of motion between the relation between force and acceleration. We will check how that actually acceleration relates with force. Then we will try to find out some kind of way to find calculate that force. Okay, but before that, we will consider some kind of examples. Just look here. Just look in this figure. There's some players are playing some kind of actual tennis ball, right? Table tennis we can consider, that long tennis we can actually consider. That ball is made up of some kind of what? Simple rubber, right? If that ball suddenly hits you, what is going to happen? Are you going to get hurt in a high amount? Okay, question mark, right? What question you have got? Second thing is, at the same way, if a high-speed cricket ball that is actually made up of some kind of wooden material, right? It is known as a deuce ball, and a high-speed cricket ball hits you. Like the same way that actually hit you in the first case, are you going to get hurt? Question mark. Now, what is going to be the answer? The simple answer is going to be, in the first case, that I'm actually showing here, and the second case I'm also showing here. In the first case, if that ball hits you, what is going to happen? You are not, though it maybe hit you, you are not going to get hurt that much because that ball is actually soft. But in the second case, what is actually happening? In the second case, you are going to get hurt badly. It may actually hurt you, that you may be getting blooded. Right? So that's the effect. Now we'll take one more example. Whenever, a truck, now you're just showing here, whenever a truck actually standing in a road, so what is actually going to happen? It is actually standing in the roadside. It is not a big thing for us. So what actually happens that we can actually pass out that truck safely. This is a fact. But if that car in motion, in a very less amount of speed, that is considered at 10 meters per second or 20 meters per second. That is not a high amount of speed. But with that heavy truck, that small amount of velocity is going to kill us if we just stand in front of that truck. Simple fact. Simple thing to understand. This is one example we have got. Now we can actually take one more example. Now we'll consider the object that we're actually discussing in a very small size. That is a bullet that actually come out from a gun. Is that bullet come out from a gun is able to kill someone? I'm showing here. What is that? What is the instrument is known as? That instrument is nothing but known as the gun that we are used to, that people are actually used in old Bollywood movie, and that made a sound like discount. And that discount sign is nothing but it's made in old Bollywood movie, but now in modern movies it is actually now changed, right? So by the way, that is a different thing. What I was saying that gun, when the bullet is come out from a gun, it is quite small in size, but it is having high amount of speed. Okay, with that speed, if that bullet enters on someone's body or some actually animal or like that, okay, some object, what is going to happen? That object is going to get hurt very badly. Sometimes what actually happen, that man or human being or just object, what you can consider that they may also die. Okay, that means what you can say, that bullet is going to hurt very badly. So from all these that I am now showing here, from all these actually examples that we have actually discussed, what we can say, that there is some kind of actually change of momentum, change of actually velocities, right? So those all things are basically relates with what? Mass and velocity. All those change in motion mainly relates with mass and velocity. That means what we can say, there may be some kind of terms which is going to relate both the two things. And when we will relate the two things, we are going to get one new term. And that is nothing but the momentum. Whenever we relate the mass and velocity, we are going to get the momentum. Okay, and that relation was first given by, and the word momentum was first given by the great scientist and the revolutionary scientist, Sir Isaac Newton. Okay, he kept the relation as, and that momentum is basically represented by small p. Okay, and that relation is nothing but m into v. That means the multiplication of both mass and velocity. Simply we can write mv. Okay, simple fact, that is the momentum is actually given by mv, right? Now, okay, what we can say, now we have to find out the actually SI unit. Okay, whenever we find a new quantity or new factor, we should always try to find out the SI unit of that. We will check it. What is the SI unit of mass? Simply kg, right? And what is the SI unit of velocity? Meter per second. So what is going to be the SI unit of momentum? Kg meter per second. We simply got it, right? Now there are again some factors. We get the momentum P equal to mv, that is, and is SI unit as kg meter per second. Now we'll check something. Whenever, okay, thus again I'm just going to consider one example. Consider this one. This is a car which is actually in race because its battery get dead. Okay, whenever a car or vehicle's battery gets dead, actually it actually not start easily. And this is basically happens when you actually not start your car or not ride your car for 2 to 3 days or 3 to 4 days like that. That automatically battery gets down. Okay, so what in that case what actually happens? You may have seen this kind of things in your neighborhood maybe. What actually happens? We request some people to push that car, right? But the thing is, once you push that car for one moment of time, is it going to start that at that moment or at once? No, obviously. We have to push that car for a certain amount of time, right or wrong? It's obvious. When I was actually young, that means I'm still young, but the thing is, when I was maybe in high school level, I used to do that in our neighborhood. Okay, and the kids are actually love to do that. Okay, but still, right now, if I saw somewhere, I just go and help them. Because I love to do that, this kind of things, okay? But you should always do that too, but in a safety manner, okay? So, whenever you do that, what actually happens? What we have to actually do? We have to push that car for a little bit amount of time. After that, what actually happens? That car starts, okay? That means what have we understood? When we are actually pushing that car, that means what we are doing? We are just applying some amount of force, right? Push and pull is nothing but force. That means right now. So, what we can say, that when you are applying force on that car, it attains a momentum. But the thing is, but very much important thing is, we have to apply that force for a little bit amount of time. Okay, once we apply the force, at once that car was not actually started. Once we apply the force for a little bit amount of time, that means consider that 2 minutes, 3 minutes like that. Okay, we then apply the force, then car actually attains some amount of momentum. That means what we can say, there, once we actually, by the way, the fact is, once we discuss the time or we include the time in the motion lesson, I told you, in physics, whenever we include the time factor, there is going to be what time? Rate. That means rate of change of motion, rate of change of moment, actually acceleration, rate of change of velocity, lots of things are there. Whenever we discuss the rate thing, that means what? We have to change that factor with time. So here we will actually consider the rate of change of momentum. Okay, that means what? For that amount of force, okay, what you can say, when we apply that force for a certain amount of time, we get the rate of change of momentum, right? So what we can say, or now what I'm going to say is the statement of the second law of motion. The second law of motion actually says, whenever there is a rate of change of momentum, that rate of change of momentum is directly proportional to the applied force. Okay, having direction in the direction of the force. Now consider that if I try to push someone in this direction, okay, what is going to happen? He will move in that direction. That means he is going to have some rate of change of momentum from rest to some amount of momentum in this direction, because I have applied the force in this direction. Okay, is it going to move in this direction? Obviously not, because I pushed him in this direction, right now. So this is the main fact. It is quite simple to understand, right? So this is the main example of the momentum, and this is the main statement of the second law of momentum. What it actually saying, that whenever we get a rate of change of momentum, that rate of change of momentum is directly proportional to the applied force on it, and having the direction in the direction of the force. That means that momentum, that is this momentum or the rate of change of momentum, is going to have direction in the direction of the applied force. That means if I am applying the force in this direction, that momentum is going to have the same direction. Okay, it's quite obvious fact, nothing to be actually get complicated here. Simple fact, if I push someone here in this direction, so he is going to move in this direction. That means what? His momentum is going to be in the same direction that I am actually pushing him. Simple fact. Okay, now we'll actually consider some kind of examples. Okay, to actually, then you will be able to actually understand very well. So consider some examples. Just look at this board. Okay, what are we actually observing? A player which is playing cricket. What is he doing here? When he have to catch a ball, what he actually do? He doesn't was catch like that. Once he caught the ball, he move his hand like that. Why? Why actually this happens? Okay, whenever we have to calculate that momentum, rate of change of momentum, what do you actually got? We got that. See, look closely in the board. We got that force is proportional to m p minus u by t. This is a factor. But look closely here. We will not actually consider this one first. We will consider this factor. F is inversely proportional to what? T. Right? This is the inversely proportional to t. That means as the time increases, that force is going to decrease. If the time decrease, the force will increase. That means it is inversely proportional, right? Whenever that player actually did one thing, that if I caught the ball like that, if I move like that, what is going to happen? Once I do like that, the velocity decreased to 0. Okay, first fact, but the time to make that velocity to 0, it's increased, right? First, if I consider ball here, the time was actually less. That means what? Time will decrease. As along with that, force will increase. But for our safety purpose, what we do? We just caught the ball here and move our hands like that. That means what? When the time increased, okay, along with that, acceleration also decreased, right? Again, we have got that forces have a relation F equal to ma, right? Now, if acceleration decreased, mass is constant for a particular object, but that means what you can say, F is directly proportional to A. Okay, with that, force is directly proportional. That means if A increases, force will increase. If A decreases, force will decrease. Simple fact. That means what we can say, if during this effect, what we are going to do, we just increase the time. So if the T increases, okay, this will obviously decrease now. That's why whenever that ball hit us, okay, it's not going to actually, we are not going to get hurt if we do this movement, because along with that, the time is going to increase, okay, till the velocity will become 0, okay. Otherwise, if we do the ball like that, that means what? Okay, time is increased, time is decreased, okay. Once the time decreases, it will increase. Once the time increases, it will get decreased. One factor is that, right? Again, whenever that acceleration decreased, okay, the force will increase. The force will decrease as well, because that force is directly proportional to area acceleration, okay. But if I do the catching like that, okay, once we catch the ball, if I do like that, if I do not move hand like that, so what is going to happen? Our acceleration is going to be a high amount of value, okay, or what we can say, we are going to stop the ball for a high amount of speed, okay. So in that case, what is actually going to happen, that force will increase, okay. That's why if we do not do this kind of movement, it is going to actually hurt us very badly, because that ball comes with very high amount of speed, okay. If we suddenly stop that ball, what is going to happen, that time is very much less. Once the time decreases, force will increase, because force is actually inversely proportional to time, right. Is that time actually decrease, it will increase. If time decrease, it will decrease or increase. Completely reversed to each other, okay. Simple that. That's why we always do like that. Again, we can take one more example. Whenever there is some kind of high jump, okay, in the figure you're actually observing that, what actually happens, they actually jump in case of a sand bed or kind of actually sponge bed. Why? Because once they jump in the sponge bed or the sand bed, what actually happens, their feet, once they land on the ground, their feet actually moves little bit in the ground if there is a sand. Along with that, what actually same phenomenon actually occurs, okay. The landing time actually increase, okay, the time actually increase. With that increasing time, that landing force become decreased, because it is again inversely proportional. Again, that acceleration, once that person's feet go down, the acceleration get decreased, because acceleration have a formula what? V minus u by t. Again, acceleration is inversely proportional to time. Once that time decrease, it will increase, okay. If the time increase, acceleration will decrease. Here the main thing is the time is actually getting increased, okay, to get at rest, right. So at that case, acceleration is going to what? Decrease, because time is going to increase. Because if this factor decreases, this factor going to increase. If this factor increases, this factor will decrease. If acceleration get increase or decrease, then force will change according to that. If acceleration increase, force will increase. If acceleration decrease, force decrease. Once we use the sand bed or the actually sponge bed, what is going to happen? Acceleration is going to decrease, as well as that landing force is going to decrease. Okay, if you consider this actually formula, where the same formula actually F equal to ma, and this is actually same formula. What is going to happen if this time decreased, that force is going to increase. If the time increased, this force is going to decrease. Here time is going to be increased, so along with that force is going to be decreased. This is nothing but the landing force actually we are just actually discussing about here, okay. This is the main concept about the momentum or the second law of motion. That's how we have to actually explain and understand the concept of momentum. I think you have actually understood the concept of momentum. Now we will actually move towards our next topic. It's time to solve actually our next topic, that is nothing but our mathematical formulation of second law of motion, okay. This topic is actually mathematical formulation of our second law of motion, okay. We have to solve this. How actually second law of motion can be expressed with the help of mathematical formula, right? So to understand that, first we'll consider one object, okay. One object we have considered, which is having a mass m, okay, which is in actually motion with an initial velocity of u, okay. Then what it actually happen, after some time it attain, after some time means we will consider that time as t, okay. After time t, what actually happen, it attain a velocity of, that is nothing but the final velocity of v, okay. That means what we can say, it is accelerated to the velocity v, right. So what we can actually say that there is acceleration, and that acceleration actually happens because of an applied force. That applied force is nothing but a constant uniform force, that is represented by F, okay. We'll come to that actually force part, but before that, what we actually do, we have to actually check something. See, the mass is constant for both the two motions, but having different velocity. One is u and another one is v. So for the initial velocity u, it is going to be momentum, and that momentum is represented by p1, okay, that is mu, right. And for the second velocity, that is v, will have a momentum of p2 equal to mv. Right or wrong? Simply yes. Now if somebody asks me, or if you ask me, sir, what is going to be the change of momentum? So what we will write? we can write actually that change of momentum, right? It will be, I will show like that it will be proportional or directly proportional to P2 minus P1. What that is actually proportionality means that the required change of momentum that we are going to actually need is directly proportional to the change of momentum of these two quantities. One is the P2, P1, another one is the P2. Okay, simple fact. Now we will actually continuing that proportionality constant and we will put the values of P2 and P1. What's the value of P2? That is nothing but the mv. So write it down, mv. What's the value of P1? It is nothing but the mu. Write it down, mu. Now again give proportionality constant. We can take out the common m, right? M. Then what is actually left inside? P minus u. This is the one that we actually got, right? Now, okay, we have to check the what actually second law of motion actually first here. I will to check that. Now, what that actually second law of motion says, the rate of change of momentum. It is actually linked with rate of change of momentum. When we are actually discussing about acceleration in the class lesson motion, what did we do? V minus u is the change of velocity. Okay, once we divide that v minus u by t, we get acceleration. Okay, and the definition of acceleration was the rate of change of velocity. Here the rate change of moment, the rate force has a definition of rate of change of momentum. So now we will check the rate of change of actually momentum. Rate of change of momentum is proportional to what is going to be there? Is proportional to keep m p minus u by t. Right or wrong? And what this actually rate of change of momentum means? Rate of change of momentum means nothing but what? Rate of change of momentum means f. And it is directly proportional to m v minus u by t. Right or wrong? And what we have got? This rate of change of momentum, okay, is nothing but what you can actually say by p minus u by t is represented by what? T. So in the next page we will actually write that we got that what? Force F directly proportional to m p minus u by t. So we can also substitute in place of p minus u by t as a. So what we have got? F is directly proportional to ma. Okay. So this is the one thing we have got. Now we have to actually remove this proportionality sign. Once we have to remove this proportionality sign, we have to actually add, okay, one proportionality constant that is represented by small k, ma. Here small k is nothing but the proportionality constant. Proportionality constant. Okay, proportionality constant. So this is the main fact about the formula. Now we will actually find the value of k by considering that F is having 1 unit force. Okay, mass is having velocity 1 kg. Okay, and acceleration is having velocity 1 meter per second square. Give this equation name as one equation. If we put these all values in equation 1, what we are going to get? Equation 1 implies F is going to have a 1 unit of force equal to K into 1 of kg, okay, into acceleration 1 meter per second square. If you solve this, what you are going to get? You are going to get the K equal to 1, right? So what will be the actually equation 1 can give us? F equal to ma, right? Because why? Since K equal to 1, right? We have actually deduced the formula to calculate for force by using this mathematical formula, right? So if somebody asks you what is the actually 1 unit of force, 1 unit of force is nothing but that actually required to change the acceleration, or with the help of that force, with the help of 1 unit of force, we can get a acceleration of 1 meter per second square, right? This is the 1 meter per second square, and this is the 1 unit of force. With the help of this force, okay, we can get the acceleration of 1 kg of mass as 1 meter per second square. That is nothing but the 1 unit of force, okay. By the way, the unit of, from this, what you can get the unit of actually force, that is having kg and it is having meter per second square, and this is actually known as Newton in the name of the Sir Isaac Newton. So that we can write unit, okay, of force is equal to what? Newton. Okay, this is the actually main formulation. Okay, this is the main formulation of the second law of motion using the help of mathematics, right? So this is nothing but the mathematical formulation of second law of motion. The second law of motion is actually saying that the rate of change of momentum is directly proportional to the applied force, okay, or the force applied, but in that direction is going to be the sense of that direction is going to be the direction of the force, right? So this is the main fact, right? This is the mathematical formula with the help of which you can actually solve it. Right now, again, okay, actually using this second law of motion, okay, we can actually calculate or we can actually deduce that first law of motion. Okay, we will check how. Okay, we have got from the second law of motion, we have got F equal to ma, right or wrong? We have got that F equal to ma. Now, this ma can be written as m into p minus u by t, right? Just do some actually cross multiplication. F into t is equal to mv minus mu. Okay. Now give this name as 1. If we consider a situation where there is no external force actually applied, that means that F is considered as 0. That means that in that situation or in that system there is no external force actually applied. So what is going to be there in equation number 1? We are going to get equation number 1 as mv minus mu is equal to 0, because this, if F becomes 0, it does not actually matter what is the time is actually, right? Whenever you multiply something with 0, we are going to get 0, right? So from here we can actually say mv is equal to mu, that mass and mass is going to cancel out, phi is equal to 0. So what we have got that for F equal to 0, we got that u equal to v. That means initial velocity is equal to the final velocity. And what does it mean? And what does actually that first law of motion says? That whenever there is no external force, if a body is in motion, okay, it will be in motion. That means that motion will not going to change. If there is no force, there will be no acceleration, okay, because force have a relation with acceleration as ma, or you can say F is directly proportional to a. If there is force, there will be acceleration. If there is force is 0, acceleration will be 0. And if what you can actually say reversely, if acceleration 0, force is 0. So that is the fact. So that what is going to say that E equal to B. From the definition of acceleration, what you can say, if there is no change of velocity, there will be no acceleration. That means what you can say, if there is no external force, the motion will be uniform motion throughout it. Okay. Again, what we can say that if U becomes 0, okay, if U becomes 0 somehow, what is the value of V? V is obviously because since U is equal to V. So you have got the two necessary conditions to actually state the first law of motion. That first law of motion says if there is no external force, that motion will be in motion, it will have a tendency to be at motion, that is represented by this one. And if the subject it has rest, it will be at rest if there is no external force, and it is represented by this one. So using this second law of motion, you can actually calculate or you can actually deduce, or you can actually state the first law of motion. Okay, this is the whole thing about the second law of motion and the first law of motion. Till now, we have actually discussed two laws of motion. That is, one is the first law of motion, second one is the second law of motion, right? From that two laws, what we have actually understood? From the first law, we have actually understand that how forces sense the motion of an object. Okay, we have to actually understand that. It's a simple concept. And from the second law of motion, what we actually understood, we actually get a way or to determine the force depending on mass and velocity. Okay, that means with momentum or the rate of change of momentum, it's to find the force. Okay, now the fact is, if some object, consider a object A, okay, when it will act on some other object B, okay, is there any kind of reacting force that is actually given by B on A? Okay, what is going to be the nature of that reacting force, right? How that actually force is going to behave, okay, what is the direction of that force? all these things is going to be understood by the next law or the last law. There is nothing but the third law of motion. Okay, what this law actually says that whenever, okay, an object acts on a different object, that different object is going to react on the same object which is actually acting on it, okay, with the same amount of force that actually getting acted on that different object. Maybe you are getting confused that from the words same object, different object like that. Don't worry about that. Just look at the figure. We are considering that two actually balls, okay, or two stones, okay. So what is going to happen whenever that actually one stone will hit the second stone? What is going to happen? That second stone is going to affect the first stone with the same amount of force, and that force is always equal in magnitude but having actually different in direction. That means whenever A object hits the B object, that means it will look like somehow look like that, okay. It will have some force on it, that is considered the F1. At the same time or simultaneously, that B will have effect of force on A with the force 2. But we can have what this actually third law of motion says that F1 is equal to F2 but having different in direction. Once the direction says that vector quantity comes into act, if the opposite direction is having, then what will be the sign? Negative sign. That means F1 is equal to F2 but having different direction. That's why we have to give the negative sign. Now we will take some kind of examples. You will actually understand this very carefully once we take the example. Okay, just look at the board. You are just observing two football players. Okay, they are colliding with each other. Now tell me one thing. When that one footballer is going to actually collide with the other footballer, tell me one thing, that is only one football player going to get hurt or the both of them? Simple answer, both of them, because they are hitting with each other with an equal amount of forces. Okay, but once they get hit, they will separate out in different direction. One may be in the right side direction, other may be in the left side direction. So what we can say, there is direction, that means what? There is a negative sign, but with equal amount of force. One example you have got. From this, what you should actually understand that though the actually forces are equal in magnitude, okay, and opposite in direction, but the thing is, at the moment when the two forces are acting like that, so the forces will act on different objects. Okay, that means what I'm trying to say, A will act on B, B will act on A simultaneously. That means the forces are acting on two different objects, F1 and F2. Okay, they don't know who is giving, the F1 and F2 don't know who is giving force on what. Okay, they only know that I am actually getting applied. Okay, they know that yes, I am actually getting applied on something, but for them both the objects are different. For F1 it is the B, and for F2 it is the A. That means what? Both the forces acting on some different objects. That is I am actually trying to explain. Simple thing. Don't try to get complicated here. Keep it simple, then you will be able to learn it simple. Okay, this is the main fact. Now we'll take one more example. Consider some spring machines, okay, spring balance, which actually measure some weights. You're just observing in the figure. Whenever we actually consider that B, okay, that B spring is attached to the rigid wall, and in the other end of the A is actually loaded with some amount of weights. What is going to happen? We are going to get the same readings in the spring balance, but the direction will be different. There is also one example. Okay, so from this thing, what we have actually understood, that there is an existence of two forces. Okay, and between the two forces, one force is going to be an acting force and other one is going to be the reacting force. That means one force acts simultaneously at that time, that there is an existence of a reacting force. So according to the third law of motion, what we can say, whenever a force acts on something, that something is going to act on that object with an equal and opposite force. That is the main third law of motion. Okay, so that's what we actually understand the concept of the third law of motion. But the thing is, from everything we actually get some kind of exceptions there. Though from third law of motion we have understood the concept that whenever we applied force on something, we get the equal amount of reacting force. Though the forces are equal, but at the same thing, when we are getting this acting and reacting force, those reacting and acting forces are going to give us some different amount of accelerations. though the forces are equal, what should be there? Their acceleration should be same, because F1 is having this one, okay, F2 is having this one. But the thing is, we are going to get some different amount of acceleration, because why? If we look very closely, what you can write? Fa equal to F by M, okay, and A2 is going to be F by M2. Okay, give some name, M1, A1, M2, A2. Here, though the forces are equal, this F is same. What is the main thing? What is the different thing? This M1 and M2. Right or wrong? Right now, this M1 and M2 are different. So, what you can say? Though the forces are same, with the difference of masses, the acceleration will be different. We will take one example. Okay, we will take one example. Okay. Just take the discount here. That means take the gun here. Okay, this is a simple example that we are actually going to get. Simple kind of example. What is going to happen here in this gun? Here, what is actually happening that whenever a gun is fired, right, the gun is applying some amount of force in the forward direction. Okay, and for that, the gun is moving in forward direction with a high amount of speed. But once the gun applied that force, that bullet actually gives some amount of force in the gun too. Okay, if I shot the gun here, the gun moves little bit backward, but the bullet moves forward with a high amount of speed. That speed with which gun move in the backward and the speed with which the bullet move is not actually equal. That means what we're going to get? The accelerations are actually different, right? So that acceleration is different because of masses, because that gun is having different amount of or higher amount of mass compared to that bullet. Right or wrong? So this is the fact. So what you have actually understood in third concept, third law of motion, that there is the existence of the action and reaction force. Both are equal but in having some opposite direction. Though the forces are equal in magnitude, but the acceleration that we are going to get from the two equal forces are different because of the masses. Because masses are different for different objects. Right? For the bullet, it is going to be the same. Okay, it is going to be a constant forever. Where till now or till when the bullet actually live. Right? Okay, this is the fact. For me, the mass is going to be same for an experiment. Right? But if you consider different object for the same experiment for that different human being, the bullet is going to be different. Right or wrong? So this is the main fact about the third law of motion. Okay, we have actually discussed the second law of motion, how actually it behaves, right? And then we have actually discussed third law of motion. Now we will take one more new topic, that is nothing but the, actually I have actually written it down. This is nothing but the conservation of momentum. Okay, this is nothing but the conservation of momentum. Okay, so to understand this one, okay, what am I going to do? Here we have actually considered one actually scenario. Okay, we have considered two balls. This one is ball and this is having, okay, we will consider the masses are like that, MA and here is the MB. Okay, we will consider the velocity as UA and UB. Okay, this is the MA and MB, MA, MB, and this velocity P1 we will consider as, sorry, VA and PB. Okay, I consider like that. So this is the condition before actually collision, right? Before collision, it is nothing but the during collision, and this is the after collision. Okay, so this is one scenario where I have considered two balls. Okay, this should be MA and this should be MB. We have actually considered that we have considered two balls. This one is a basketball, this is a football, right? And both of them are having some kind of different mass, right? It is having mass MA, it is having mass MB. Here, that MA, that is the main first ball, is moving with a velocity of UA, and the second ball is having velocity UB in this direction. Okay. Now the fact is, to get collision in this situation, that UA velocity should be greater than UB, because if the two velocities are
equal or that UA becomes less than UB, there will be no collision. Okay, consider that one car is moving here. Okay, this is one car and this is another car. Okay, if their velocity is equal, are they going to collide? Obviously not. If their velocity increases, this will collide this one like this, right or wrong? Obviously it will collide that. Similar thing will happen here. Okay, so this is the initial velocity of the balls before getting collision. Okay, and this is the scenario of the collision. Okay, but during this collision, what is going to actually happen? One more thing will actually happen. This first ball will give a force on second ball. Okay, and that force is actually represented by F of AB. That means ball A is acting a force on ball B. Right or wrong? But from this third law of motion, what we have get? When there is an acting force at the same time or simultaneously there is a reacting force, right? And that force is basically given by this second ball to the first ball, and that direction will be in this direction, and that force is actually represented by F of BA. Simple. This is the main thing we have actually got from our third law of motion. Okay. Now, it will last for, we have considered the time 3 seconds. You can actually consider 2 seconds, 1 second, anything. Okay. So, again after getting collision, okay, what is going to happen? They will obviously separate out. Okay, they are not going to stuck for their whole life. So, after getting collision, they actually separated. But they have actually attained a final velocity VA for the ball A and VB for the ball B. Now, that conservation of momentum actually says that the momentum, or you can say that total momentum before collision is always equal to that total momentum after collision. That means that momentum is actually conserved. So, what we have actually proved, write this down, we have to prove that MAVA plus, sorry, not PA, sorry, MAUA plus MBUB should be equal to MAVA plus MBVB. Right? You have to prove that. Okay. So, first we'll actually go through like that. We will check how to actually solve it. Okay. Now, we have to actually prove that MAUA plus MBUB equal to MAVA plus MBVB, right? So, from the third law of motion, we have actually understood the concept of, or from the second law of motion, sorry. From the second law of motion, we have actually understood the concept of the rate of change of momentum. And that rate of change of momentum is actually leads us to what? Force. So, for the first ball, okay, it actually first having an initial velocity UA, then it actually having a velocity V after collision, but having a same mass. So, for that actually change of velocity, we are going to get a change of momentum, or we are going to get a rate of change of momentum. We can actually change, or you can actually write that rate of change of momentum. Okay, rate of change of momentum, and it will be actually represented by F of AB. Sorry, F of AB, because rate of change of momentum is actually represented by force, and here that A ball will give a force on B, right? So what you can write it is as F of AB, and F of AB will be equal to MA, right? What is the final velocity? VA minus, what is the initial velocity? UA. What is the time? T. Okay, this is the relation. Okay, and for this condition, for the ball B, what is going to actually happen? Similarly, we can actually write rate of change of momentum F of BA, okay, for that ball B, okay, for that ball B, that ball B will act on ball A, okay, with a force F of BA. That's why it is actually represented by F of BA. So write it down, F of BA equal to, the mass is what? MB. So what is the initial velocity? UB. What is the final velocity? VB. So what will be the velocity change? VB minus UB. Now what is the time? t. Once you divide something by t, it is going to be the rate. Okay, by the way, we have got f of AB as this one and f of BA as this one. Now, from the concept of third law of motion, what you have got, that two forces, when they are acting and reacting, both the two forces are equal in magnitude but having some different amount of direction. So what we can write, f of AB is equal to f of BA, but the directions are opposite. Look closely here. This is the direction, okay? This is the direction of f of AB, right or wrong? And this is the direction of actually f of BA. So both the directions are opposite but having some equal amount of magnitude. So from here we can actually put the values. MA, okay, VA minus UA, okay, divided by T, minus in MB, VB minus UB by T. Cancel out the T's. Okay, so what we are going to get? We just, if we solve it, we are going to get it MAVA minus MAUA equal to minus of MB, okay, VB plus MBUB. If we arrange this actually thing, what we are going to get? We will get MAUA plus MBUB equal to MAVA plus MBVB. Okay, this is the relation we have to actually prove, and from this relation what we have actually got, we have now actually prove it, right? We got that MAUA plus MBVB equal to MAVA plus MBVB. We have actually got it here too. MAUA plus MBUB plus MAVA plus MBVB. This is the relation that we actually prove. Okay, so we have actually proved it. So from this we can actually say that whenever, okay, there is a system, okay, or that conservation of momentum actually says that when two balls, okay, collide having some different masses, okay, that once they collide and after collision, if they separate out, according to the conservation of momentum, okay, if we say that momentum is actually conserved, if we say that momentum is conserved, so there have to be a scenario that the momentum before collision and momentum after collision have to be actually conserved or have to be equally constant or have to remain same. Okay, you may ask me, sir, what is the meaning of conservation? Conservation is nothing but for a system of something or for a system of particles, if something remains constant throughout the process, okay, if there is some kind of changes are there, but though there is some kind of changes, the all thing is on all the actual observations and all the quantities or all the calculation remains constant, or then it is actually known as the conservation of something. Okay, here we are actually discussing with the conservation of momentum, right? So here basically what we have to actually care for, if the momentum is actually conserved, so that momentum before collision, or you can say the total momentum before collision, have to be equal to the total momentum after collision. Otherwise the momentum will be not conserved. Okay, if it is not actually happening. Okay, that means if we represent the total momentum before collision as PB, okay, if it is not equal to the total momentum after collision PA, then the momentum conservation rule will be violated. Once it is equal to, that is PB is equal to PA, then the actually momentum conservation rule will be considered, okay, and it will be satisfied. So this is the whole concept about the conservation of momentum. Okay, so by the way, till this video we have actually understood all the theoretical part of this lesson. Okay, and by the next video we will actually start our problem solving part. Okay, from this lesson lots of problems actually comes, and in your exercise part lots of problems are there. Okay, we will try to solve as much as possible like using this laptop screen. Okay, I hope you are just liking this kind of actually way I am actually teaching. I am using in this video, I am using actually both board and laptop screen. Okay, using a tablet, right? So actually this kind of things are actually necessary now, since we are actually moving towards our digitalization. So this kind of digital study is also necessary. Okay, this is the thing about the whole lesson, forces and laws of motion. So the theory part is actually ended here, and I will actually move towards our next part.